all. Today we'll discuss on Unit 5, the language modeling. This language modeling covers the topics of introduction, n-gram models, language model evaluation and parameter estimations, and language model adoption, types of languages models, and language specific modeling related problems, and multilingual and cross-lingual language modeling. First we'll go for the what is actually the language modeling. So language modeling is nothing but will be take the different context of a words, and will be find out whether the next word defines that is predicted from the previous words or not, or we can also take the precedence of the words or sequence of the words. So this is called as a statistical language model, and it specifies the probability of generating of a next word based on the sequence of the previous words. So this can be represented as W equals to W1, W2 up to WT. So T is our target word, and which will be predicted based on the word 1, word 2 and word 3 and all n minus 1 words. So this can be called as a epsilon star. So this is a language model which computes the probability of the words based on the previous words or parameters. So the epsilon, the summation of the words is the list of the unique words available within that particular sequence. So this selection of units of words or sequence of words, the model is called as our language modeling. So based on the language modeling, we can select the sequence of the words to predict our current word. So and this language model is also combined with the different types of models, and we can also say it as the condition we can give the based on the required target word. Okay, in general applications is one is in the speech recognition, and another one is within the language models which are used within the different types of chat applications and others. So whenever we are started typing a word, then immediately it guesses the next word and it recommends the next word, so that based on the previous word it recommends the next word. Okay, or based on the sequence of the words which we have typed already, based on that it can recommend the next word. So in the speech recognition also, based on the speech recognizer works based on these acoustic model scores, okay, which defines the language model scores, which decodes the existing words and gives the next word based on the decoded value or acoustic signal. Okay, and within this, one of the model is called as the n-gram model. So this n-gram model is actually, we can call it as the probability of a word sequence of arbitrary length. Okay, this is actually not possible in a natural language, because natural language is generally gives a infinite number of word sequences of the different variable lengths, so that we can say the probability may not be possible within the natural language models. So the probability of P of W, that is predicting of a word W, the probability of predicting of a W word. Okay, that you can write it as P of W equal to P of W1 to WT. That is the probabilities of first word to target word. The summation of all the probabilities or product of all the probabilities can be called can be used to get the probability of a W word. So this we can define as P of W1, the probability of W1, because W1 it doesn't has any words prior to that, so that we can directly take a probability of a W1, and which is a product rule of I1 to T. So P of Wi, the word can be generated with the help of I minus 1 word and I minus 2 word up to the current word, or up to the first word. So that is if you want to predict the Wi word, you will be take all the words related probabilities from the I minus 1 to the first word. So each and every these product values, the probabilities products will give us the probability of the word, current word, or the word which we want to predict. Okay, so this we will call it as the n-gram approximation or n-gram model. So assumption of these all preceding words and n minus words is generally used within the n-gram model, and actually this n minus 1 words cannot be maximum is not related to the current word prediction. So sometimes we may have the different word as a target word, so which is not related to the sequence of the words, so that we can say it as this is not exactly equal but approximation. That is we can say it as a recommended, that is the current word probability is based on the previous words, that is we cannot say it as a equal, it is a approximated. So there may be the possibility with the previous words to predict the current word, or they may not be. Say for example, if I am getting a probability of the previous words as the 90%, so there is a probability of a current word generation based on the previous words is 90%. So there is another 10% of a chance to get the another word, so that we cannot say it as a equal, it is a approximated. Okay. So this model is also called as the n minus 1th order Markov model, because this assumption is independent of the current word and independent of the preceding words also. Okay. So and next we will see the language model evaluation, how this language model will be evaluated. Okay, that is how can we say that this model is a good, or this model is a best or average, or is not relevant. So how can we evaluate it? So that you can do with the help of different types of a criteria. There is a two criteria which are used for this language evaluation. So one criteria is the coverage rate, okay, and another one is the perplexity. Perplexity. So based on these two criteria, we can evaluate that whether the language model is a proper or not. So coverage rate is, it measures the percentage of the n-grams, that is how much of a words which are relevant to the our required word or not. That is, say for example, I am saying that the some sentence as how or you. So once you type the how or, then it recommends the you. So if the target word, that is the sentence related target word and the previous words, say if the previous words are 100% used for to predicting of the next word, and it is a correctly predicted, then we can say that coverage rate is 100%. Say if the previous words are dependent for only 50% to predict the next word, then we can say that coverage rate is the 50%. So based on that, we can say that how much of our model is giving a coverage percentage. Okay. And next, in the some special cases are like out of vocabulary rate. That is how much of the words which are out of the vocabulary of the current context or current sentence. So based on that, if the percentage is 0, then we can say that the words are related to the our required vocabulary. Okay. And next evaluation of a language evaluation is the second evaluation criteria. So this is based on this formula. This is called as actually discrete probability distribution. So and this is actually defined based on the two raised of the entropy. So entropy value will be used as a power of a 2. So PPL, perplexity of the P, that is the word model or P. So 2 power h of P. So hypothesis of P. So 2 power negation of summation of x, P of x log to P of x. So here we are taking a x probability and log of the x probability. So this summation of this product, that is the summation of these products, will give us the value of a PPL of a P. So we can be use it as for like so it can be derived into the fixed size of a words. Okay, set of a words are fixed size like W1, W2 up to WT. So this can also be computed as the Q of Wi, which computes the probability of the ith word, that is whatever the word which you are going to take a probability, so are going to predict. Okay, that word you can use it use with the help of this formula. So in place of x, you can use the I equals to 1 to t, okay, so that you can calculate the required ith word related probability. And the continuation to the language model evaluation. So this Q of Wi is also called as n-gram probability. So this equation can be written as 2 power minus of 1 by L I equals to 1 to t log 2 P of Wi, okay, which is dependent on Wi minus 1 to Wi minus n plus 1 words. Okay. So whenever you are comparing the different language models, these perplexities are used for to get the comparison of the language models and to decide the which language model is the best and which language model is generating a same number of a sequence of a words or same type of a words. Okay. So this is actually called as average number of equally likely successor words. Okay, whenever you are transforming the words from the one language to another language or from one position of the word to the another position. Okay. So this model has no predictive powers. Okay. So, and perplexity is generally equal to the vocabulary size. Say if you are use the 10 unique words in your sentence, okay, then we can call it as our perplexity is the 10. Okay. So next one is for getting of a better prediction, generally we'll use this criteria as the one. So the main goal of this language models is generally to minimize this criteria and to get the better word sequences and good or bad word sequences. Or whenever you want to differentiate the good and bad word sequences, then also we'll use the language model evaluation and this p value. Okay. So this optimization is generally not for the minimizing of this p value, but it is to know the difference between the different language models and to know the different types of word sequences, difference between the different types of word sequences. Okay. So next one is the parameter estimation. Okay. So this we will continue within the next class.